Good day, we're going to discuss our assigned topic in integrated system entitled Techniques in Uncertainty Reasoning and Certainty Factors. Reasoning under uncertainty. Most tasks requiring intelligent behavior have some degree of uncertainty associated with them. The type of uncertainty that can occur in knowledge-based systems may be caused by problems with the data. For example, data might be missing or unavailable. Data might be present but unreliable or ambiguous due to measurements errors. The representation of the data may be imprecise or inconsistent. Data may just be users' best guess. Data may be based on defaults and the defaults may have exceptions. The uncertainty may also be caused by the represented knowledge since it might 1. Represent bases of the expert that are based on plausible or statistical associations they have observed. Second, not be appropriate in all situations, e.g., may have an indeterminate applicability. Given these numerous sources of errors, most knowledge-based systems requires the incorporation of some forms of uncertainty management. When implementing some uncertainty schemes, we must be concerned with three issues: how to represent uncertainty data, how to combine two or more pieces of uncertainty data, how to draw inference using uncertainty data. We will introduce three ways of handling uncertainty: probabilistic reasoning, certainty factors, Dempster-Schiffer theory. So the first to discuss the probabilistic reasoning is Angelica Dusaran, and the certainty factors will be discussed by Donnalyn Gamarcha, and then Dempster-Schiffer theory is I'm discussing.
The first techniques of uncertainty reasoning that I am discussing is probabilistic reasoning. There are three types of probabilistic reasoning. First is classical probabilities, second compound probabilities, third is conditional probabilities. First is Mahoney ang classical probability. The oldest The oldest and best defined technique for managing uncertainty is based on classical probability theory. Let us start to review it by introducing some terms. Sample space. Consider an experiment whose outcome is not predictable with certainty in advance. However, although the outcome of the experiment will not be known in advance, let us suppose that the set of all possible outcomes is known. This set of all possible outcomes of an experiment is known as the sample space of the experiment and denoted by S. For example, if the outcome of an experiment consists in the determination of the sex of a newborn child, then S stands for 6, G stands for girl, B stands for boy. If the experiment consists of flipping two coins, then the sample space consists of the following 4 points. So, mao ang following 4 points. Event in any subset A of the sample space is known as an event. Mutually exclusive events. A set of events A sub 1, A sub 2, and A sub n. In a sample space, A's are called mutually exclusive events. If A sub I intersection of A sub G equals null set, I is not equal to G, comma 1 is less than or equal to I, comma G is less than or equal to N. A formal theory of probability that can be made using three actions. So, mao ni ang three actions. This axiom states that the sum of all events which do not affect each other are called mutually exclusive events is 1. As a corollary of this axiom, P of E sub I plus P of E sub I equals 1, where E sub I is the complement of event A. So, mo ni ang mga reason sa kanisiya. Kaning 1 and 2. Then, ang 3 is P of E sub 1 union A sub 2 equals P of A sub 1 plus P of A sub 2, where A sub 1 and A sub 2 are mutually exclusive events. In general, this is also true. That is, an event is a set consisting of possible outcomes of the experiment. If the outcome of the experiment is contained in A, then we say that A has occurred. Compound probabilities. Events that do not affect each other in any way are called independent events for two independent events A and B. So, mao ni ang formula sa independent events. Independent events that the events A sub 1, A sub 2 to A sub n in a sample space A are independent A. So, mao po ni ang formula niya. For each subset, so mao po ni ang mga formula sa each subset. If events A and B are mutually exclusive, then P of A union of B equals P of A plus P of B. If events A and B are not mutually exclusive, then P of A union of B equals P of A plus P of B minus P of A intersection of B. This is also called addition law. Conditional probabilities. The probability of an event A given B occurred is called a conditional probability and indicated by P of A over B. The conditional probability is defined as P of A over B equals P of A intersection of B over P of B for P of B is not equal to 0. Multiplicative law of probability for two events is then defined as P of E intersection of B equals P of B over B P of B, which is equivalent to the following. P of E intersection of B equals P of B over A P of A. Generalized multiplicative law. So, mao ni ang mga formula sa generalized multiplicative law. In summary, ang probabilistic reasoning is na siya three types of probability. First is classical probability. Second is compound probability. Third is conditional probability. So, para dili mo maglibog atong ta sa tagsaon. Ang classical probability is na siya tulo ka axioms. Ang compound probability is na siya addition law. Then, ang conditional probability is na siya multiplicative law of probability and generalized multiplicative law. Natay example. As an example of probabilities, table below shows hypothetical probabilities of a disk crash using a brand X derived within 1 year. So, ang brand X of brand X atong ipang-add. Crash C 0.6, 0.1 equals 0.7. So, mo na ang iyang total of rows kang 0.7. So, sa no crash C na pod, 0.2 plus 0.2 1 equals 0.3. The total of columns 0.8, 0.2, then 1.0 ang total of rows. So ang ikaduhang example sa hypothetical probabilities of a disk crash is gipambutangan na siya og mga probabilities. So mani siya kani. Then ang ikatulong example sa probability interpretation of two sets using above tables, the probabilities of all events can be calculated. Some probabilities are number 1 is P of C equals 0.7. Number 2 is P of C equals 0.3. Number 3 is P of X equals 0.8. Number 4 is P of X equals 0.2. Number 5 is P of C intersection of X equals 0.6. The probability of a crash and using brand X. Bayes theorem. So, mao po niya ang mga formula sa theorem. Bayes rule. As we know, rule-based systems express knowledge in an if-then format. If X is true, then Y can be concluded with probability P. If we observe that X is true, then we can conclude that Y exists with the specified probability. For example, if the patient has a cold, then the patient will needs 0.75.
The second technique of uncertainty reasoning is a certainty factor. So certainty factor is another method of dealing with uncertainty. This method was originally developed for the Bayesian system. Certainty factor story and evidential reasoning. Certainty factor story is a popular alternative to Bayesian reasoning. A certainty factor or CF, a number to measure the expert's belief. The maximum value of the certainty factor is, say, positive 1.0 definitely true, and the minimum negative 1.0 definitely false. For example, if the expert states that some evidence is almost certainly true, a certainty factor value of 0.8 would be assigned to this evidence. Uncertainty terms under interpretation in Bayesian. So, mo ni ang mga terms. Definitely not, kunya, naa siya ay corresponding nga certainty factor. Ang definitely not, negative 1.0. Almost certainly not, negative 0.8. Probably not, negative 0.6. Maybe not, negative 0.4. Unknown, negative 0.2 to positive 0.2. Maybe, positive 0.4, probably positive 0.6, almost certainly positive 0.8, and definitely positive 1.0. An expert system with certainty factors, the knowledge base consists of a set of roles that have the following syntax. So, sa programming languages, naman siya syntax. So, sa certainty factor po, na po siya kaugalingon nga syntax. If evidence, then hypothesis, certainty factor. Where CF represents belief in hypothesis H given that evidence E has occurred. The certainty factor story is based on two functions. Measures of belief or MBHE. Ang H og A means hypothesis, nang E mao'y evidence. The measure of increased belief in H due to E. And the measure of disbelief MB HE, the measure of increased disbelief in H due to E. Probability of hypothesis is equals to 1, mo ni ang inyuhang formula nga gamiton. Formula sa measure of belief. Otherwise, if P of H or probability of hypothesis is equals to 0, mo ni ang formula imong gamiton, ang measure of disbelief. P of H is the prior probability of hypothesis H being true. P of H over E is the probability that hypothesis H is true given evidence E. The values of measure of belief and measure of disbelief range between 0 and 1. The strength of belief or disbelief in hypothesis H depends on the kind of evidence E observed. Some facts may increase the strength of belief, but some increase the strength of this belief. The total strength of belief for this belief in a hypothesis is, mao ni siyang formula, certainty factor. Example, consider a simple rule. If A is X, then B is Y. An expert may not be absolutely certain that this rule holds. Also, suppose it has been observed that in some cases, even when the F part of the rule is satisfied and object A takes on value X, object B can acquire some different value Z. If A is X, then B is Y, certainty factor is 0.7, B is Z, certainty factor is 0.2. The certainty factor assigned by a rule is propagated through the reasoning chain. This involves establishing the net certainty of the rule consequent when the evidence in the rule antecedent is uncertain. So, mo ni formula. So, example, if sky is clear, then the forecast is sunny. Certainty factor is 0.8. And the current certainty factor of sky is clear is 0.5. Then, so ato ang kuan ang atong formula sa certainty factor assigned by a rule. So, certainty factor, open parenthesis H, comma E is equals to 0.5, sky is clear, times 0.8, forecast is sunny, is equals to 0.4. So, ang result can be interpreted as it may be sunny. Kaya ang 0.4 sa uncertain terms kay maybe. Conjunctive rules such as, so mao din ni ang syntax. O sa programming languages, naman siya syntax. So sa certainty factor na po siya, paugalingon niya syntax. If evidence is sub 1 and evidence is sub n, then hypothesis H, certainty factor. The certainty of hypothesis H is established as follows. So mao ni ang formula sa certainty of hypothesis. For example, if sky is clear and the forecast is sunny, then the action is wear sunglasses. So, ang iyang certainty factor is 0.8 and the certainty of sky is clear is 0.9 and the certainty of the forecast of sunny is 0.7. Then, mo ni ang iyang formula. Certainty factor, open parenthesis, H, A sub 1 is an intersection of A sub 2 is equals to minimum, open bracket, 0.9, comma, 0.7, close bracket, times 0.8 is equals to 0.7 times 0.8 is equals to 0.56. For disjunctive rules such as, so sa disjunctive rules na po check ko yung syntax. If evidence is sub 1 or evidence is sub n, then hypothesis H, certainty factor. The certainty of hypothesis H is established as follows. So, ano ni formula sa disjunctive rules? For example, if sky is overcast or the forecast is rain, then the action is take an umbrella. Certainty factor niya is 0.9. And the certainty of sky is overcast is 0.6 and the certainty of the forecast of rain is 0.8, then muna iyahang formula. Certainty factor, open parenthesis, H, comma, E sub 1, union of E sub 2 is equals to maximum 0.6, comma, 0.8 times 0.9 is equals to 0.8 times 0.9 is equals to 0.72. So, duha ang kuan. Sa certainty factor na duha ka rules. Conjunctive rules o disjunctive rules. Pero lahi-lahi sila og formula og syntax. So, sa conjunctive rules, ang iya is intersection. A sub 1, intersection of A sub 2. Pero ang disjunctive rules, union sila. A sub 1 is union of A sub 2. O ang conjunctive rule is minimum ang gikuha, pero sa disjunctive rules is maximum. Common sense suggests that if we have two pieces of evidence, A is X and B is Y, from different sources, role 1 and role 2 supporting the same hypothesis, C is Z, then the confidence in this hypothesis should increase and become stronger than if only one piece of evidence had been obtained. When the same consequence is obtained as a result of the execution of two or more rules, the individual certainty factors of this rule must be merged to give a combined certainty factor for a hypothesis. Suppose the knowledge base consists of the following rules. Rule 1, muna ang formula. If A is X, then C is Z. Ang certainty factor niya is 0.8. Sa rule number 2, if B is Y, then C is 7. Ang certainty factor niya is 0.6. So, what certainty should be assigned to object C, having value Z if both rule 1 and rule 2 are fired? To calculate a combined certainty factor, we can use the following equation. So, mani ang equation sa pag-calculate sa combined certainty factor. So, where ang CF1 is the confidence in hypothesis H established by Rule 1, while CF2 is the confidence in hypothesis H established by Rule 2. CF1 and CF2 are absolute magnitude of CF1 and CF2 respectively. The certainty factors theory provides a practical alternative to Bayesian reasoning. The heuristic manner of combining certainty factors is different from the manner in which they would be combined if there were probabilities. So, makombine ra sila o probability sila. The certainty theory is not mathematically pure, but does mimic the thinking process of a human expert.
Third techniques of uncertainty reasoning that I am discussing is Dempster-Shafer theory. Here we discuss another method for handling uncertainty. It is called Dempster-Shafer theory. It is evolved during the 1960s and 1970s through the efforts of Arthur Dempster and one of his students, Glenn Schiffer. This theory was designed as mathematical theory of evidence. The development of the theory has been motivated by the observation that probability theory is not able to distinguish between uncertainty and ignorance, owing to incomplete information. Dempster rule of combination. Let M sub 1 and M sub 2 be mass assignments on theta. The frame of discernment, the combined mass is computed using the formula, special form of Dempster's rules of combination. So this is the formula of Dempster's rules of combination. For instance, using our hostile aircraft is example, based on two pieces of evidence we obtain. So this is the given of the Dempster rule of combination. E.g., the entry T sub 11 is calculated as this. T sub 11 B equals M sub 1 B and F. M sub 2 B equals 0.7, 0.9 equals 0.63. Once the individual mass products have been calculated as shown above, uh, then according to Dempster's rule, the products over the common set of intersections are added. So M sub 3 B equals M sub 1 and M sub 2 B equals 0.63 plus 0.37 equals 0.90. So mo na siya ang bomber. Then M sub 3 B and F equals M sub 1, then M sub 2 B F equals 0.07. So this is the bomber or the fighter. Then M sub 3 and M sub equals M sub 1 and M sub 2 equals 0.03 non-belief. So that's all for today and thank you.